Welcome in another video. Today we are going to discuss the methods of preparation of benzene. So let's start. Methods of preparation of benzene. The first method here is reduction of phenols. Okay, here we have a phenol plus a reducing agent just like zinc to give me benzene here plus zinc oxide. Let's understand what happens in this reaction, how zinc acts like a reducing agent. Here we have the oxidation state of zinc is zinc 0, and it's a change to zinc 2 positive because we have oxygen here 2 negative, then the zinc should be 2 positive. So from zinc 0 to zinc 2 positive, oxidation takes place, then zinc, oxidation takes place to the zinc. Then zinc acts as reducing agent. Okay, easy peasy, right? And let's look at this carbon here. This carbon is, the oxidation state of this carbon is positive 1 because the oxygen is pulling the electrons. And here the carbon should be negative 1 because the electrons are moving towards the carbon here. So what actually happens is reduction. So oxidation reduction process takes place here. So the reduction of phenol always gives me the benzene. So zinc acts as a reducing agent. It just grasps or it just takes away this oxygen uh, from the um, from the benzene ring here. Okay, so this is the reduction of phenol. Then the second method is dry distillation of sodium benzoate. Here we have sodium benzoate plus sodium hydroxide and calcium oxide. This mixture is called soda lime. This is called soda lime. So when you add a mixture of soda lime to a sodium salt or potassium salt, sodium or potassium salt of carboxylic acid, just like um, benzoic acid. Actually, we had in the first place benzoic acid, then we added sodium hydroxide to neutralize it to get sodium benzoate, just like here. And when we add the soda lime, we perform a dry distillation process or called decarboxylation reaction. This reaction is called decarboxylation reaction because you get rid of the carboxylic group here. So when you add the soda lime, the actually the NaO and COO and A are taken away, or they are produced, or sorry, they produce sodium carbonate here, just like here. And finally, hydrogen is left on top of benzene ring here. Okay, so this is actually not the mechanism of reaction. This is just for simplification reasons, right? So Na2CO3 is removed and is produced in the products, and we get benzene here. Okay, this is for the second method. How about the third method? Okay, third method is from catalytic reforming of normal hexane. So this is actually normal hexane, n-hexane, C6H14, to give me benzene plus hydrogen. We actually need a catalyst, platinum in the presence of strong heating. So when we try to understand what's happening, not the exact mechanism. This is just for simplification, not the exact mechanism. The exact mechanism is something else, but this is just for simplification to let you memorize it easily, right? So C6H14, this is hexane. Let me draw it. CH3, CH2. Actually, if I want to write the open chain normal hexane, it will be just like this. 1, 2, 3, 4, 5, 6. What is it? This is normal hexane, right? This is normal hexane, right? So CH3, then CH2, CH2, CH2. I will write it in different way. 1, 2, 3, 4. and 5, and finally CH3 just like this. CH3 just like this. This normal hexane is just like the normal hexane as I have drawn it here with this method. Okay, okay. So how can normal hexane form benzene, right? So I will show you now. I will just like get rid of this drawing and I will show you now. And okay, so when you remove 1 mole of hydrogen, 1 mole of hydrogen is H2. 1 mole of hydrogen is like H2, one molecule, right? 1 mole of hydrogen gas is when you write it when you write the chemical formula of hydrogen, it should be H2, not just H. So when you remove 1 mole of hydrogen, you remove 1 mole. So when you remove 1 mole, you form one double bond minus 1 mole of hydrogen plus one double bond. Okay, so let's try it here. I will remove 2 hydrogens, one from here and one from there, and I will write a double bond instead. Okay, so this is the first one. So I formed the first double bond and I removed 1 mole of hydrogen. Okay, so how about removing another mole of hydrogen? Okay, just like here, 1 mole of hydrogen, and I will form a double bond. So double bond is formed. So removing another mole of hydrogen gives me another double bond. Okay, removing. So what about this? How would you form a double bond? First, you have to link these carbons. If you want to link these 2 carbons, you will remove 1 hydrogen, right? So I will remove 1 hydrogen here and remove 1 hydrogen from there. So I will get like CH2 and here CH2 and I will form just a bond. This is a bond, but the bond between carbon and carbon, not hydrogen. It's just for simplification, right? Or I can write it like this. So here is CH2, just for you to understand me. So here is CH2 and here is CH2, just for simplification. So, and I will write here a double bond. Okay, let me write what I did. I removed 1 mole of hydrogen to form, to close, the ring. Okay, so, and another mole of hydrogen removal to form a double bond. So I will now remove it. I will remove 1 mole of hydrogen, another mole of hydrogen to form another double bond, just like here. Okay, this is benzene, right? If you look here, this is benzene. From which compound? From normal hexane. So we can transform normal hexane into benzene with catalytic reformation. It's actually called catalytic reformation or catalytic reforming. So we use a catalyst, platinum, in the presence of heat. Okay, to give me benzene, and we get 4 moles of hydrogens, and I have shown you how this process was done. Okay, okay. Then the fourth method is from fractional distillation of coal tar. Actually, if I do fractional distillation to coal tar, and I heat from 80 to 82 Celsius degrees, I get benzene. And I think you get me what fractional distillation is, right? If you don't understand what fractional distillation is, please comment down and I will make a video about it. Okay, then see you in the next video. Bye.